Now let's look at the mistakes people make with queues and see most of them come from a missing guard or a forgotten reset. Let's go through the common ones. There are 4 common queue bugs. For each one we give the mistake, the symptom you would see, and the fix. First, using bare front is equal to rear to mean empty. The trouble is that front is equal to rear is also the full state. So this check reports empty when the queue is really full, and the next in queue overwrites a live cell. The fix is to track an explicit count, or to reserve one empty slot. Second, forgetting the mod capacity on an index update. The index walks past capacity -1, and you read out of bounds. The fix is that every index update is index plus or -1, plus capacity, mod capacity. Third, leaking linked-to nodes. Memory grows without bound across many in-queue and deque cycles. The fix is that every deque must free the node it removes. Fourth, not resetting rear to null when the linked queue empties. The next in queue writes through a dangling pointer. The fix is, if front is null, set rear to null after every deque. Here is a realistic bug. The key fact first: empty and full share the same indices. At capacity 5, both count 0 and count 5 land on front equal to rear, say index 2. Only count tells them apart, so a guard that reads the indices alone is doomed. This buggy full guard tries to detect full from the indices. It returns rear +1, mod capacity equals front. Here is why it fails. At true full, count is 5 and front equals rear equals 2. So rear +1 mod 5 is 3, which is not 2. The guard returns false, says not full, and in queue runs anyway. It writes at data of rear, which is data of index 2, overwriting the live front element. Now the fix. The full guard reads count. Is full returns Q arrow count equals Q arrow capacity. And is empty returns Q arrow count equals 0. Count is the one value you can trust. Front and rear alone are never enough to tell empty from full.